Good afternoon. So बेटा ग्रेट सर्कल सेलिंग कहाँ तक पहुँचे? Were you able to find out intermediate positions?
Yes, sir.
Good afternoon, sir.
Yes, sir.
Okay, very good.
Sir, question
Any
number 8 में थोड़ा सा डाउट है सर.
question number 8. Okay, just a minute बेटा. हाँ अब बताओ बेटा.
सर इसमें मैंने PAX ट्रायंगल यूज किया था. वी आर गोइंग वेस्टर्ली फ्रॉम A to B.
Okay.
मैंने PAX ट्रायंगल यूज किया था सर एंड D long is coming negative. So D long can the value of angle can come negative also, sir, and then we can fit in the longitude.
Okay, the value is coming negative from the calculator, right?
Calculation, yes, yes.
Okay. बेटा
And
आपने
yes, sir.
ये जो एंगल निकाला है इसमें कुछ ना कुछ इन्वर्स लिया होगा.
यस सर, इन्वर्स तो किया था, वो मिडिल पार्ट का वही इन्वर्स किया सर, और तो कुछ नहीं है. वैसे तो कोई इन्वर्स नहीं किया.
साइन थीटा, कॉस थीटा, टेन थीटा, व्हाट वाज इट?
tan theta sir, sin and tan.
इट वाज टेन थीटा.
इन्वर्स मैंने साइन का किया था सर, वही मिडिल पार्ट का, एंड हैव यूज्ड tan फॉर्मूला.
ओके, टेन इन्वर्स किया है आपने. जस्ट अ मिनट, लेट मी सी.
And D long was coming easterly, sir, because the PX will lie on the east side of A.
नो प्रॉब्लम बेटा,
Since we are going,
नो प्रॉब्लम. मुझे पहले ये बताओ कि हैव आई सेंट यू द PDF डॉक्यूमेंट ऑफ द कोसाइन फार्मूला स्फेरिकल ट्रिग्नोमेट्री? मैंने भेजा आपको?
नहीं सर, नहीं.
ओके ठीक है, मैं अभी आपको भेजता हूँ.
फार्मूला तो भेजा था.
फार्मूला
भेजा है सर, फार्मूला वाला PDF भेजा सर.
स्फेरिकल ट्रिग्नोमेट्री जिसमें कोसाइन फार्मूला और नेपियर रूल थे.
सर फॉर्मूला नहीं, वो तो सर आपने
सर,
पहले असाइनमेंट
Napier
और
rule-
सॉल्यूशन भेजा था ना सर, वो तो
ओके,
फॉर्मूला नहीं भेजा सर.
नो प्रॉब्लम, आई विल सेंड इट. जस्ट गिव मी अ मिनट. बेटा आपके व्हाट्सएप ग्रुप पे मैंने अभी एक स्फेरिकल ट्रिग्नोमेट्री का PDF डॉक्यूमेंट भेजा है. लेट मी ओपन इट अप हियर ऑल्सो. So can you see it on the screen now, beta?
Yes, sir.
Okay. So आपने tan इनवर्स लिया था ना बेटा, ये लास्ट में एक मैंने आपको प्रिकॉशन बताई है, प्रिकॉशन विद साइन, कॉस एंड टेंजेंट रेशियोज whenever you are using these in your calculations, तो इन चीज़ों का ध्यान रखना है. Now if you have taken a tan inverse and it was a negative angle, okay, now ये जो फॉर्मूला है बेटा देखो, tan of minus theta is equal to tangent 180 minus theta. So whenever we get a negative angle from tan inverse, add 180 to the negative angle for getting the angle of the spherical triangle.
सर 1 मिनट लिख लेते हैं सर, 1 मिनट.
हाँ बेटा, मैंने भेज दिया है आपको, ये सारा डॉक्यूमेंट ही भेज दिया है आपके व्हाट्सएप ग्रुप पे.
ओके सर.
हाँ, if you want you can write down, no, not an issue. इसमें मैंने तीनों रेशियोज के साथ आपको प्रिकॉशन बताए हैं. सो कॉस इज ओके, कॉस में कभी कोई दिक्कत नहीं आती है, एंड साइन में कभी कभी दिक्कत आ सकती है. whenever we take sine inverse there are always two possibilities. One is the angle which you get on the calculator and other is 180 minus that angle. So always
Sir,
check
I have
which one.
taken sine
You had
in the
taken
question.
sine?
Actually, sine. Yes, sine inverse.
साइन में नेगेटिव आया बेटा?
Yes sir, negative आया था सर.
हाँ, फिर तो कुछ गड़बड़ है बेटा, साइन में तो
नेगेटिव
नेगेटिव
तो नहीं आ
आता.
रहा सर, इसमें कोई जीरो आ रहा है सर, उसमें तो 90 माइनस पी इक्वल टू 0.
PAX ट्रायंगल लिया था.
सर एक्चुअली एक्स का वैल्यू जो आ रहा है वो -21 डिग्री 55.7 आ रहा है.
PAX तुमने लिया था, वो साइड PX इक्वल टू 90 था, इसलिए लेना.
हाँ, PX is 90 ना, PX side is 90. That's why I had taken this.
उसका सर्कल जो बनाते हैं हम लोग से बनाया था ना, साइड के हिसाब से बनाया है ना.
हाँ, साइड के हिसाब से बनाया.
करता हूँ कैलकुलेट.
तो मैंने पीवीएक्स ट्रायंगल लिया, पीवीएक्स से तो सही आ रहा है.
हाँ, PVX में ले रहा था लेकिन उसमें 2 पार्ट 90 है. सर, if 2 parts are 90 then it will be okay. Can we use Napier rule there? One
Yes,
side
you
and one
can
angle
use.
also.
Yes, why not? You can use that. Okay, let
Calculation
me
में
make
कुछ गड़बड़ी हो
a triangle for this. Let's see it here. एक मिनट, अभी देखते हैं बेटा. Just give me a minute. Okay. So our positions are 10 south, 40 north. And we have 150 west to 160 east. Okay. So we are going in with which direction, beta?
Sir, we will go westerly.
Okay.
वेस्टर्ली डायरेक्शन.
So northwesterly direction is where we are going. So हमारी जो triangle बनेगी, we will take the north pole. ये north pole आ गया हमारा. And one position, our position A would be somewhere here. Position B would be somewhere here. And जो हमारी triangle बनेगी, that would be something like this. This is the equator. Right, beta?
Yes sir.
Okay. So अब आपने इस ट्राइंगल में सबसे पहले तो AB डिस्टेंस निकाल लिया, एंगल A और एंगल B भी निकाल लिया. Now we want to find out this particular point. Let's name it as X.
सर जो इनिशियल फाइनल टॉसेज मतलब वर्टेक्स पोजीशन में थोड़ा मिनट से डिफरेंस हो रहा है तो चलता है या फिर पूरा एग्जैक्ट होना चाहिए?
हाँ बेटा चलेगा, बिकॉज ये बुक में आंसर्स निकाले गए हैं ना, they are using Haver signs, they are not using the scientific calculator, so your answer should be more accurate.
ऐसे वो मैच नहीं हो रहा है।
No problem, a little bit difference in decimal places is okay. Okay, अब बेटा इस ट्राइंगल में तो you have taken PAX.
Yes sir, PAX sir.
Okay, so PAX में जो हमारी PA side है that becomes 100.
Yes sir,
And
that is pre-calculated in question number 3.
yeah, PA side is 100. And second thing which you have taken here is
Angle A.
angle A.
Angle
What
A
is
we know.
what is
Yes,
the angle A which you got, beta?
angle A sir, just
39.2.
39.2.
सही आ रही है इंस्टॉलर से।
So 39 degree 14.3 minutes.
39 14.3.
39
14.3.
14.3. Okay. 39 14.3. Uh,
39.2 लिख सकते हैं राउंड
yeah,
ऑफ।
that's okay. You can do that. But इसमें बेटा आपने नंबर 3 जो क्वेश्चन है इसका आंसर चेक किया? Is the initial course matching?
Yes sir, exactly, everything is matching sir.
Okay. What is the initial course they have given? North 39 West.
Yes sir, correct.
Okay.
Yes
all
sir,
right.
now 39 14.3 minutes.
So अब हमने इस पे लगाया नेपियर्स। So we have the side px coming here, then we have 90 minus, this will be minus 90 and 90 minus. So px is the 90-degree part which is on top, then we come to angle P, then we come to PA, then we come to angle A, then AX, and then angle X. So what we know is side PA known to us, angle A known to us, and what we need to find out is angle P.
Angle P.
Very good. So sine of 90 minus PA is equal to tangent adjacent. So that comes to tangent A minus 90 excuse my handwriting, that's with a mouse, into tangent of P. So sine 90 minus theta is equal to cos theta. So that gives us cos of 100 tangent of A minus 90. What is tangent of A minus 90 beta? A is 39 14.3. So this will be tangent of minus
A minus 90
degrees.
50 degree 45.7 आया था सर।
50 degree 45.7. Okay. ओके सो ये कैलकुलेटर में करके देखो बेटा कितना आता है आंसर। आई थिंक इट शुड बी लेस देन 90 बेटा।
So 0.14182.
टेक ए tan inverse also।
8 degrees 04.3.
8 degrees
04.3
Okay.
minutes.
8 degrees 04.3. So that's 8 degrees 04.3 beta. You were saying this is coming negative?
Yes, sir. I was saying negative.
Okay. If this is 8 4.3, longitude of A is 150 west. So X point जो है इसका longitude आ जाता है 158 degrees 04.3. So just check the answer.
वैसे भी सर cos
Yes,
100
yes sir, यही है.
10 जो नीचे वाली वाली वो नेगेटिव ही रहेगी तो कैंसिल हो जाएगा.
हाँ, the cos 100 will also be negative. Tan of minus theta or minus 50 degree will also be negative. So both will get cancelled out and you should get a positive answer.
Yes sir. सर इसमें ये
Answer correct.
PX ट्रायंगल कंसीडर किया है. अगर PXV भी कंसीडर कर सकते हैं ना सर इसमें.
This one beta?
नो सर, PX and V वर्टेक्स.
Okay.
वर्टेक्स.
वैसे इस सवाल में वर्टेक्स निकालने की जरूरत ही नहीं है. This is
वो तो
this
पहले
can
से निकाला हुआ है ना सर हमने क्वेश्चन 3 में.
okay. All right. हाँ वो भी कर सकते हैं बेटा.
ठीक है.
वो भी कर सकते हैं.
सर एक क्वेश्चन था, ये जो एंगल P है PAX ट्रायंगल में, दिस शुड
Right.
बी ईस्टर्ली ना सर? इट शुड कम, आई मीन द D long, because
बेटा
PX
देखो.
is actually on the east side of PA, because we are going westerly, sir.
You are going westerly. You are going from
Yes,
A to
yes.
B in this direction. You are going westerly. So beta that tells that X should be west of A. Always remember these directions.
So we are going from other side of the hemisphere. Initially we were going from A to B, which was easterly.
D long will be easterly. D long will be easterly.
D long वेस्ट है.
But you have
No,
to cross
B is on the
longitude,
east side. B is on the east side and A is on the west side.
B is on easterly side beta.
Yes, sir. And we are going westerly from other side of the hemisphere, sir. Because initially we are going from easterly.
रूट लेंगे ना तो
Then
टू ईस्ट जाएंगे तो
D long
नॉर्थ
का-
वेस्ट में जाएंगे. शॉर्टेस्ट रूट लेंगे, लंबा रूट नहीं लेंगे.
no, A to B easterly was coming long route. A to B westerly is shorter, na? That's why we plotted westerly.
but
And
you have
now
to cross
B is lying on the
longitude.
west side. B is on the east side
So B
of
should be
A.
on the right side.
A is 150.
No,
so
sir.
you
I
have to
mean
add 30
B
to
Right
longitude.
is
is on the
correct.
left side
जब
because
B
we are
is
going
on the
from other
west
side of
side
the
with
hemisphere.
respect to A.
No, no. This position what sir have plotted is okay because we are going from other side of the hemisphere westerly. The eastern distance is longer. That's why
या
the D long was coming westerly.
क्रॉस करके जा रहे हैं तो शॉर्टर डिस्टेंस होगा.
हाँ, so B is on the east side actually. B is east. So A PX should be easterly, no? I mean PX should be on the east side of PA.
PX should be on the right side of A. That's what you are saying.
No, sir.
तो
सर
फिर
मैं
बेटा
बोल रहा हूँ
PX
कि
तो दो ही तो चॉइसेस हैं. या तो
Sir,
PX
इसको
A के
180
लेफ्ट में हो
degrees
सकता है
180 degrees
या
में
PX
लेके
A के राइट में हो सकता है. तो तुम बता दो बेटा कहाँ लगाना है.
इसका वर्टेक्स तो सर पी
सर
के
आएगा तो इधर ही सर,
में
ये तो
आएगा.
सही है.
वर्टेक्स तो
बट
पी
मेरे को
के
एंगल में डाउट हो गया है कि वो ईस्टर्ली आएगा, डी लॉन्ग ईस्टर्ली आएगा, उसमें डाउट हो गया है सर. बिकॉज बी ईस्ट साइड में है, अदर साइड ऑफ द हेमिस्फीयर जा रहे हैं और बी ईस्ट में है. फाइनल पोजीशन इज ऑन द ईस्ट ना सर, दिस इज ईस्ट.
बेटा जो ये लेफ्ट डायरेक्शन है ये तो हमेशा वेस्टर्ली डायरेक्शन होती है ना बेटा.
सर सिंपली ऐसे है बट वी आर नॉट गोइंग लाइक दैट. वी आर गोइंग फ्रॉम अदर साइड ऑफ द हेमिस्फीयर वेस्ट टू ईस्ट. दैट इज द शॉर्टर डिस्टेंस.
We are going like this only beta. Whether you are on the other side or this side of the hemisphere, you are going like this only.
Yeah, we are going like this sir, but B is east, no sir? B is east.
No, B is west of A beta.
बी की लॉन्गिट्यूड पोजीशन ईस्ट है बट इट विल बी वेस्ट ऑफ ए ऑलवेज.
B का longitude easterly है, that I agree, but B is west of A.
from A we have decided we are going more westerly, and we came on the B
Okay.
at easterly
Okay.
longitude.
Okay. So it means, sir, this north, south, east, west, what you have plotted, this always remain the same. Just the directions will change.
या ये जो मैंने बनाया है
Always.
बेटा, this is always correct, irrespective of whether you are on the Greenwich meridian or 180 degree meridian. Anywhere this is correct. The right side
Because
will always be
I was
east.
just thinking, sir, I have a doubt. I was just thinking that we are going from the other side of the hemisphere, and when we will see from the other side, west will become east, and east will become west.
No, it will
From
never
other
become.
side.
It will remain like this only, beta. The right side will always be east and the left side will always be west.
Okay. ठीक है
Okay.
सर, फिर तो सही आएगा.
अगर इसको और भी सिंप्लीफाई करना चाहते हो, देखो ए का लॉन्जिट्यूड 150 वेस्ट है ना बेटा. A longitude is 150 west. Let me open up another whiteboard. Let me mark the longitude of A here. The longitude of A is 150 west, right?
Yes, sir.
Okay. Now, if I go in this direction, तो अगला जो मेरा longitude आएगा या meridian आएगा, that will be 160 west और 140 west. क्या होगा?
सर इस साइड में तो वेस्टर्ली बढ़ेगा सर. 160.
तो it has to be 160 west ना? Correct?
Yeah, this is clear, sir. This is 100% clear. I'm just
Very good.
thinking on a sphere
अब
that we are
एक मिनट
going.
बस और रुक जाओ बेटा, एक मिनट. इससे अगला वाला क्या होगा?
जी सर. Increasing, sir, 170.
और इससे अगला वाला क्या होगा बेटा?
That will 180 degree meridian.
Very good. And इससे अगला वाला क्या होगा?
170
Then
east.
it will start as 170 east. Easterly side.
करेक्ट. अब हमारा जो बी पॉइंट था उसका लॉन्जिट्यूड क्या था?
160 east.
वेरी गुड. सो ये आ गया बेटा 160 ईस्ट ईयर.
Yes, sir.
So B would be here on this meridian, A would be here on this meridian, and you are looking at it from the other side of the earth. That means you have 180 degree meridian in the middle. The vessel is going like this.
Yes, sir. Correct, sir.
And this is westerly direction.
Yes, sir.
Right बेटा? Clear हो गया?
Clear. 150 degree west इधर आ. ये तो क्लियर था सर मेरे को पहले भी डायरेक्शन ऐसे. बट यही मैं सोच रहा था कि ये जो वेस्ट है ये अपने राइट हैंड साइड में और ईस्ट अपने वेस्ट हैंड साइड में आ गया है सर.
No, it never comes, beta. The right hand side, wherever you look at Earth, no matter which place you are looking at, wherever you look at it, कोई भी Mercator chart उठा लो बेटा. Any Mercator chart of any part of the Earth, the right side will always be east. देखो 090 right side होती है ना? तो हम Earth पे कहीं भी चले जाएं तो 090 तो ईस्टर्ली ही रहने वाला है. And 090 will always be on the right side, towards the right side.
यस सर. अभी ये जो आपने डायग्राम भी बनाया है सर, अगर मैं इसके ऊपर देख रहा था तो मेरे को ऐसे लग रहा था ये वेस्टर्ली, मेरे को वेस्टर्ली डायरेक्शन समझ में आ रही है सर. वी आर गोइंग वेस्टर्ली, दैट इज क्लियर. बट वेस्टर्ली लुक्स लाइक ऑन द राइट साइड एंड ईस्टर्ली लुक्स लाइक ऑन द लेफ्ट साइड इफ वी ड्रॉ डायग्राम.
पर मैंने तो बेटा तुम्हें यहाँ अर्थ की डायग्राम बना के दिखा दी. सो अब तो कोई डाउट ही नहीं है.
ठीक है सर, कोई नहीं, वो क्लियर हो गया. डायरेक्शन सेम रहेंगी हमेशा.
Right. Right side will always be east, left side will always be west. Okay बेटा?
सर तो इसमें जो कोर्स होगा जहाज का वो हम वेस्टर्ली बोलेंगे?
हाँ बेटा, it will be the course. देखो अगर तो आप ग्रेट सर्कल की बात करोगे तो कोर्स चेंज होता रहेगा. So
नहीं, मतलब जो उसका डायरेक्शन होगा वेस्टर्ली होगा?
Yes, it will be westerly बेटा.
ओके सर, ओके।
ओके, और बताओ बेटा, और क्या डाउट है?
जीसी एक्सरसाइज के आंसर्स हैं आपके पास पीडीएफ में मैच करने के लिए, सॉल्यूशन?
So you want great circle some exercise, extra exercise?
This is Captain Subramaniam both the solution, full solution. So we can match the steps and how to proceed in exam.
ओके
यस
बेटा,
सर।
जो प्रैकनेव वाले क्वेश्चन है ना, ये तो बहुत सिंपल हैं, सो यू कैन ट्राई देम आउट। ये तो सिर्फ नेट प्रैक्टिस हो रही है अभी हमारी।
हो गया है
वंस
सर, तो लिए हैं मैंने, लेकिन सही प्रोसीजर किया है नहीं, कैसे करना है उसके लिए बोल रहा हूँ।
नो प्रॉब्लम बेटा, लेट मी फिनिश ऑफ द कंपोजिट सेलिंग विद यू। मैं एक बार आपके साथ फिनिश कर लूँ, फिर मैं आपको एक बड़ी असाइनमेंट देने वाला हूँ जिसमें 10+ क्वेश्चंस होंगे और उनके सॉल्यूशंस भी दूंगा। वंस यू अटेम्प्ट देम, उनके सॉल्यूशंस भी मैं भेज दूंगा, सो दैट यू कैन सी योर वर्किंग।
ओके सर, थैंक यू।
राइट, और बताओ बेटा।
सर ये तो वैसे ही बोल सकते हैं ना, जैसे अमेरिका से जापान सेल करें, पैसिफिक क्रॉस करें तो सेम वेस्टर्ली डायरेक्शन में।
एग्जैक्टली बेटा, यू आर राइट।
उसमें जब हम सब ग्रेट सर्कल बनाते हैं तो वो हमारा लिमिटिंग लैटिट्यूड क्रॉस हो जाता है, तो उस केस में फिर हम मैनुअली अपने आइडिया से उसको नीचे कर लेते हैं लैटिट्यूड की, इसके ऊपर नहीं जाना है।
राइट, उसी को कंपोजिट सेलिंग बोलते हैं बेटा, अभी करेंगे।
ओके
अमेरिका टू जापान ही जाएंगे, डोंट वरी।
ओके सर।
ये उसमें सर जापान टू वैंकूवर जाएंगे या ऊपर ही जाएंगे तो वो अल्यूशन आइलैंड आता है, उसके लिए लिमिटेशन डालेंगे।
राइट 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 राइट, बिल्कुल सही है बेटा। कंपोजिट सेलिंग का यही कॉन्सेप्ट है। एक्चुअली जो ग्रेट सर्कल सेलिंग हमने की है उसकी यही एक डिसएडवांटेज है, दैट इट टेक्स अस टू हायर लैटिट्यूड। और हायर लैटिट्यूड के तो बेटा अपने डेंजर्स हैं। द biggest danger to shipping, that's iceberg, because of which we have Titanic. Okay, so along with ice, numerous other dangers, sub-zero temperatures, problem with the running of engines, problem with the ice hitting the hull of the ship, navigational equipment does not work, deck machinery में दिक्कत आती है, sub-zero temperature में ice accretion की problem है, the vessel could lose stability and it could capsize. If you go in thick ice, there is a danger of the vessel getting beset. Visibility is usually restricted in higher latitude. Weather is most of the times rough, bad weather, heavy swell, unlimited number of problems. So हम लोग ग्रेट सर्कल सेलिंग को यूज़ करते हैं to save on distance. But sometimes this may take us into higher latitude and into dangerous waters. So to avoid that, अब हम बेटा डिस्टेंस तो चाहते हैं कि सेव हो, बट नॉट एट द कॉस्ट ऑफ द शिप। ओके, सो डिस्टेंस सेव करने के चक्कर में वी कैन नॉट रिपीट द टाइटैनिक ना, सो दैट इज़ वाई वी यूजुअली कंबाइन टू फॉर्म्स ऑफ सेलिंग, ग्रेट सर्कल सेलिंग एंड पैरेलल सेलिंग, इनको हम लोग कंबाइन करते हैं and ensure करते हैं that we remain in safe latitude. That is what we call as composite sailing. So that is our next topic which we are going to discuss. So और कोई doubt बेटा before we go ahead? Okay. So आगे चलें बेटा?
Yes, sir.
Yes, sir.
Okay. So as I told you the concept of composite sailing. So हम लोग अभी composite sailing का concept पहले understand करते हैं and then we will see how do we do this. So let me show you the video. Just give me a minute, I'll set up the video. Okay. Now, beta, before we start off with composite sailing, do you know what is parallel sailing, beta? Parallel sailing?
Sir, वही sir along the parallel of latitude departure upon D long equals to cos mean lat.
Very good, beta. Very good. Yes, you are right. Parallel sailing is when we move along the parallel of a latitude, and उसमें हम जो formula use करते हैं वो बिल्कुल सही बोला आपने. Departure upon d long is equal to cos of m lat or cos of mean lat. In this case, the latitude will be the same. So our course is either 090 or 270. So this is what we use in composite sailing along with the great circle sailing. So let's see this formula briefly and then move on to the concept of composite sailing.
Let us quickly brush up our concepts of parallel sailing, which I'm sure all of us are aware of. Now, when a vessel sails along a given parallel of latitude, that means along an easterly course that is 090 degrees true, or a westerly course that is 270 degrees true, the sailing is referred to as parallel sailing. We already know why it's called parallel sailing, because you're moving along a given parallel of latitude. Now, departure is the east-west distance between two places expressed in nautical miles. So please note, it has to be expressed in nautical miles, and it needs to be the east-west distance between the two places or points. Now we have a parallel sailing formula, which gives us a relationship between d long and departure, and we all know it. Cosine of latitude is equal to departure upon d long. Obviously, this cos lat cosine is a trigonometric ratio. So obviously the units of departure and d long will be same. So here we have the world map on the screen. Let us say we need to depart.
Beta, you remember this formula? If you want, you can note it down. That is the parallel sailing formula. Now, departure in this case, beta, is the distance we travel on the parallel sailing, distance we travel along the parallel of a latitude. So to calculate the distance, you need to know what is the d long between the two positions and what is the latitude on which you are moving. So putting these two things, you can easily calculate the distance between your initial and final positions.
Same. So here we have the world map on the screen. Let us say we need to depart Tokyo in Japan, which comes up on the screen, marked as point A, with its coordinates also showing up. And we need to reach Seattle in United States, which also comes up on the map, marked as point B, with coordinates of the Seattle also showing up on the screen. Obviously, our preferred route shall be great circle sailing to save on time. And in this case, you can see it shall be across the 180th meridian, across Pacific on an easterly track. Now let us quickly draw a PAB triangle between Tokyo and Seattle on the globe. Here we have point A representing Tokyo. Here we have point B, Seattle in United States. We join them with a shorter arc of great circle. So this is from A to B, the arc great circle track between A and B. This is the vertex of this great circle track. So we have the GC track from A to B as well as the vertex of the.
So this is the actual PAB triangle on the Earth surface, beta. P is the pole, A is our initial position, B is our final position. Now, Just a minute, let me highlight the mouse. So you can see A is our initial position, then B is our final position. AB is the great circle track between them. And if you see this dotted line going through the earth and coming back, this is the complete great circle on which we are moving. Papa alpha side is the colat of position A. Papa Bravo side is the colat of position B. And the vertex is here, beta. You can see all the parallels marked here. And you can see that the highest latitude this track is attaining is somewhere here. Right, beta? Up to here, everything clear?
Yes, sir.
Yes, sir.
Okay, all right.
This track. Now we can see in this case, the GC track is easterly because the D long from A to B is easterly. Let's now draw the meridians of A and B. So the two meridians come up on the diagram, and what we get is a PAB spherical triangle, which we all know that if enough information is available, can be solved. Now this white track out here is the rhumb line track between the two locations, and we can see that the rhumb line distance obviously is greater than the GC track, and therefore the preferred track shall be the GC track from A to B.
So you can see this rhumb line track also, beta. The rhumb line track is a longer distance, but the advantage is that you see rhumb line track is going much down south. The highest latitude you are going to attain or moving on a rhumb line track is the latitude of B, no more than that. But if you follow a great circle track, the latitude will be much higher than the latitude of both the positions A and B. So this is the advantage and disadvantage of the great circle track compared with the rhumb line track. So there is a saving in distance in the great circle track, but at the same time you may go closer to the danger, or you may pass over land, like in this case we are passing over this point.
Preferred track shall be the GC track from A to B. For the sake of clarity, let us see how these two tracks, that is the GC track and the rhumb line track, would appear on a Mercator chart. Now, this is how the tracks would appear on a Mercator chart. On Mercator chart, the GC track would be a curved track, and a rhumb line track would be a straight line track, we all know.
So is it clear, beta? The first thing which we saw was on the globe, on the actual earth, and now this is how it is going to appear on a Mercator chart. Okay, let's now proceed ahead and see mnemonic chart, how it will appear on a mnemonic chart. Have you seen a mnemonic chart on board, beta?
Yes, sir, beta.
Okay, all right. Usually ships which go in transocean passages, they have mnemonic charts, set of mnemonic charts to help in planning the Great Circle passage. So let me show you this path on Great Circle, on mnemonic chart.
That on Mercator charts, because the meridians are parallel straight lines, therefore the rhumb line tracks are straight lines. Now here it may appear that GC track is a longer distance, but that is not so. It is the GC distance along the GC track which shall be the shortest distance. How would these two tracks look on a mnemonic chart? Let's look at that. Now here we have how it would look on a mnemonic chart. On a mnemonic chart, it's polar mnemonic. GC track would be a straight line and rhumb line track would be a curved track. So hope these two comparisons also bring in clarity.
So this is how it appears on a mnemonic chart, beta. On a mnemonic chart, the Great Circle tracks are straight lines, and rump lines are curved.
About how these tracks appear on different projections. Now, having appreciated as to how these tracks appear on different projections, we come to the most important part of our discussion. And for that, we go back to the PAB spherical triangle constructed between Tokyo and Seattle a while back. Now on this globe, we can see this PAB triangle, with this one being the GC track between A and B. On examining this track, what do we see in this part of the track? We see that some part of the track appears to be passing over land or maybe non-navigable waters. Now, this could be one reason, or there can be other contributory factors also, which may force a vessel to decide on the highest latitude that it would not like to cross during her voyage. The highest latitude that the vessel would like to reach and not cross is referred to as limiting latitude. Let us say, factoring in all the requirements, in our case, let us say we decide to limit the latitude to 50 degrees north. Here comes the parallel of latitude of 50 degrees north. And now obviously it's very clear that the vessel cannot go from A to B along the GC track because.
Okay, so now we see this limiting latitude on the chart beta. So in this case, they have selected 50 degree north parallel of latitude as the limiting latitude. So how is this limiting latitude selected? Now, if there are any non-navigable waters or the vessel's track is moving over land, then certainly you will be able to get it from the chart that my track is clear up to which particular latitude. Otherwise, if you are in open sea and there are no restrictions otherwise, the limiting latitude is decided by looking at the routing charts of that area and the sailing direction, the pilot books. So these sailing directions and routing charts, they give us information like what is the frequency of bad weather in that particular area, what is the extent of icebergs, so up to which parallel of latitude are we expected to get icebergs, how is the visibility condition with respect to the latitude, after which particular latitude we will be having more frequent instances of restricted visibility. So we take care of all these things. We can check out the weather in the area. The routing chart will tell us that where it is expected that the weather will be very bad. We can check the swell heights, the wave heights with respect to the latitude, and this helps us in deciding. The master and navigating officer can then decide that which is a safe latitude for my ship to follow. So in this case, they have picked up this 50 degree north parallel of latitude. So we do not want to cross this latitude. We do not want to go northwards of this particular latitude. Now the easiest possible option appears to be. So what could be the easiest possible option, beta?
सर आधा जीसी हो जाएगा फिर 50 डिग्री मैक्सिमम जो आएगा वो 50 लेट के बाद फिर डिसेंट करना शुरू कर दें.
Right. So the easiest option which comes to the mind is you keep on following the GC track. As soon as you reach here on your limiting latitude, now you follow the parallel track. That means moving along the parallel of a latitude of 50 degree north. And once you reach back here, again follow the GC track and reach to your destination. That seems to be the easiest possible way. But there is another possible way which, if we follow, will give us even shorter distance than this, and at the same time will not cross the limiting latitude also. So what is that way with which we can avoid latitudes higher than 50 and follow a track which is even shorter than this? Let's see.
Some part of it is crossing the limiting latitude. In such cases, to strike a balance between the shortest possible distance and also meeting the requirements of not crossing the limiting latitude, the vessel may use combination of sailing. In this case, combination of great circle sailing and parallel sailing. What does the vessel do? Vessel figures out a GC track whose features include A, it passes through departure position A. 2, it has its vertex on the limiting latitude. So here is the GC track passing through A with its vertex being here on the limiting latitude.
So beta, you can see now that we have not followed the original great circle track. जो पिंक कलर का ट्रैक था, original GC track, we have not followed it at all. What we are following is a great circle track which passes from our starting position A and which has its vertex on the limiting latitude. जो पिंक वाला ट्रैक था उसका वर्टेक्स तो हायर लैटिट्यूड्स में था, पर जो ब्लू कलर का ट्रैक अब हमने बनाया है, that track has its vertex on the limiting latitude. So did you understand it up to here, beta? Any doubts up to here?
No, sir.
Okay, good. Let's proceed ahead.
V1 represents the vertex of this blue GC track, AV1. Now, this is a GC track, obviously. This is the meridian of V1, the vertex.
Now, beta, if this point V1 is the vertex of the blue color great circle track, can you tell me what will be angle V1? Angle V1 in this diagram?
90 होगा sir.
90 degree.
Very good. So angle V1 would be 90 degrees. We know at the vertex the great circle track is east-west and it cuts the meridian at 90 degree angle. So this will be a 90 degree angle.
We all know that this meridian will make an angle of 90 degrees at V1. So what do we get? We get this shaded right-angled spherical triangle.
So हमें अब एक triangle मिल गई है, Papa Alpha Victor 1. So PAV1. So we will be solving this triangle in composite sailing, and it's a special spherical triangle. All three sides are great circles and it has a right angle at Victor 1. So ये पहली triangle है जिसे हम later on solve करेंगे. First we'll understand the concept. So ये पहला great circle track हमने follow किया. Now after this we will follow another great circle track at the end of our passage. So let's see that also.
PV1A is a right-angled spherical triangle. Likewise, we figure out a GC track passing through B, again having its vertex in the limiting latitude. So you can see this one. Here is the vertex of this GC track marked with V2. So what is BV2? It's an arc of great circle passing through B, having its vertex in the limiting latitude.
So बेटा आपने देखा जो थर्ड लास्ट में जो लेग हमने फॉलो की, पहली लेग हमने फॉलो की अल्फा टू विक्टर 1 एंड जो लास्ट लेग हमारे पैसेज की होगी दैट विल आल्सो नॉट बी अलोंग द ओरिजिनल जीसी ट्रैक. जो पिंक कलर का ओरिजिनल जीसी ट्रैक था उसे हमने बिल्कुल छोड़ दिया है. What we have followed is a new blue color GC track and it is such a great circle which passes from B and has its vertex at the limiting latitude, which we have represented as V2. So the blue circle here which we see arc of the great circle is such a great circle which passes from our destination point B and has its vertex on the limiting latitude. So this is also clear beta up to here?
Yes sir.
Okay.
Here is the meridian of V2, and obviously this will also make an angle of 90 degrees with the GC track. We get another right angled spherical triangle, PV2B, shaded out here. Now we get two right angled spherical triangles, PV1A and PV2B.
So you see beta, we have another special spherical triangle, Papa Bravo Victor 2. So ये दो spherical triangle हमारे पास आ गई हैं, and from our starting point A, we go up to V1, Victor 1. From V1, we follow the parallel track and go to Victor 2. And from Victor 2, we follow the second great circle track up to our destination. So this is the track which we follow during composite sailing. Now you can see we have not crossed the limiting latitude at any location. We are always within 50 degrees latitude. We have not crossed it. And secondly, the distance traveled now is shorter than following the pink color track and the limiting lat. I'll explain to you how the distance is shorter in another diagram. Later on, I'll show you this diagram. So this is our composite sailing track. We first do GC sailing from A to V1, then we do parallel sailing from V1 to V2, and we do next leg of our great circle sailing V2 to Bravo B. So all clear up to here beta?
Yes sir. और सर ये V1 से V2 लेके अपना parallel sailing हो जाएगा.
Yeah, that's right beta. V1 to V2 will be parallel sailing.
Okay sir.
सर जो ये V1 है, it is the vertex, so right angle triangle दोनों साइड बनेगा सर कि एक ही साइड बनेगा?
दोनों साइड बनेगा बेटा. It will be 90 degrees on both the sides.
So angle V1 on both side, angle V2 also both side 90 degree.
Yes, it will be 90 degrees on both the sides.
Okay.
Sir, but the track
Okay,
is parallel of latitude and the other one is GC.
Right.
How it will be 90 degree on parallel of latitude, sir?
Okay. बेटा पापा टू विक्टर 1 जो है ये क्या है?
That is meridian, sir.
Meridian of this place. और ये जो ऑरेंज कलर की लाइन हमने ड्रॉ की है ये क्या है?
Parallel of latitude, sir.
So one is meridian, another is parallel of latitude. They will intersect at?
Meridian.
90 degree
They
angle.
also intersect at 90 degrees.
Right. So this angle will be 90 on this side also and on this side also. Both these angles are 90 degrees.
Okay, sir. Okay.
Okay. Same is the case here. The angle V2, whether it is between this shaded triangle Papa Bravo Victor 2 or on this side, it will be 90 degrees.
Okay, sir.
अब बेटा मेरे माइंड में एक डाउट आ रहा है कि ये जो बीच वाली ट्राइंगल है पापा विक्टर 1 विक्टर 2, इसमें भी तो 90 डिग्री के दो एंगल बन रहे हैं, इसमें भी नेपियर रूल लगा देते हैं?
No sir, it is not a great circle.
It's not a spherical triangle.
Spherical triangle.
वेरी गुड बेटा, वेरी गुड. सो आप ये समझ गए हो अब. ये जो बीच वाली ट्राइंगल है दिस इज नॉट ए स्फेरिकल ट्राइंगल. व्हाई? बिकॉज इसकी जो V1 V2 साइड है it is not a great circle, it is a small circle. It is a parallel of latitude which is a small circle. So good, we have understood the concept. We are almost done for our session beta. So let's give it a break here and we will continue on this when we meet on our next session. I have a session with you tomorrow, so we will continue with this. Yeah, ठीक है बेटा. Okay then, bye bye. See you tomorrow.
Thank you.
Thank you.
Thank you sir.
Thank you.